Hello again. Good day, everyone. Welcome to our fourth session of BEXEL Manager online education. I'm Mileta Pejovic, again with you, BIM Manager at BEXEL Consulting, and I'll teach you how to work using BEXEL Manager. If you have any question, use our Q&A or chat, so I'm going to try to respond to your questions at the end. Yesterday, we talked about element grouping using selection sets and how to create simple animations. And today, I'll show you how to execute clash detections in BEXEL Manager, how to collaborate the issues with other participants on the project, and how to use quantity takeoff module in order to create quantity takeoffs and calculate the quantities of your BIM model. So as most of you know, one of the extremely helpful and beneficial uses of BIM models is for design coordination, even in the early stages of the project. And common and frequent clash detection analysis and collaboration between all participants in the project are significantly important and reducing additional costs and time on the project in the later stages. So today I'm going to start with a clash detection and collaboration and coordination issues found in your BIM model. So we're going to start or continue with the same BIM model where we finished yesterday. So it's actually the same BIM model demo sample, which have updated the new building, and we have all selection sets we created yesterday automatically visible. We also have all other possible way of segregation of your BIM model, and these are all system-based, and that's something that we talked about previous sessions. And today we're gonna continue with clash detection module, and then later on with the quantity takeoffs. So if you want to analyze your BIM models regarding collisions between specific BIM model elements or specific disciplines of your BIM models, we can use clash detection module, which is positioned in a lower part of the user interface. And also, if you want to use some brief clash detection analysis, such as checking if your BIM model have some duplicates or similar things, you can use clash detection tool in the upper part of the window, which have almost the same tools, but these are, let's say, simplified. And if you want to, let's say, just check if your BIM model, which we updated and used for update this new, for example, structural building, have some duplicate elements, we can easily select these elements by selecting the source or selecting structural elements from the BIM model using already created selection sets, or using spatial structure, whatever we choose, and then use the option to check duplicate elements. And this is something that frequently happens, that some design teams forget to delete or accidentally make some duplicate elements. So if you want to check these kinds of issues, and these are some kind of brief BIM checkings for duplicate elements, you can use the option to run clash detection for selected elements only or run for selection duplicates. Difference is, if you're checking the selected elements for the duplicates, only elements which have the same bounding box around them are actually analyzed, and these are the main way, or actually the main analysis which is used to check if your BIM model have duplicates or the same, sharing the same bounding box around them. Otherwise, if you use the option run for selection only, it means that the system will analyze all your selected elements for any type of collision, not just for a duplicate, but even just touching elements between each other. So in case we just want to check duplicate elements, not some touching of the elements which sometimes are not really clash, we want to use option run for duplicates. And in this case, the system will run the new window, which is the main window for clash detection analysis, and then we can just hit run. The system will tell us about the identified issues, in this case for the duplicate elements, and then if we hit OK, the listed or the found issues, found duplicate elements in this case, are listed in the lower list of your found issues, found duplicates, and easily, just by double clicking on any found issue, we can isolate these duplicate elements. So now I'm just going to duplicate and double click on this found issue, and here you see that these columns are duplicate, and all these elements are duplicates. Easily we can select all found issues, which have 26 in total, and by right clicking on selected issues in the lower table, you can use option to select all elements which are included in these issues. So we're gonna select all duplicated elements just by selecting left or the right part of these elements which are included in the collision. If we select all elements, it means that we're gonna select original elements and their duplicates. So if we just want to in some way isolate duplicate elements without using original ones, we can use left or right selection. In this case, I'm just gonna select left, and these are all selected elements which are duplicates. And we have 26 identified duplicate elements. And then we can easily collaborate with our design teams in several ways. One of the ways is to select the IDs of these elements using the option to select from the Manage tool, to select the IDs of these elements, from the selection option, select the IDs of selected elements, and we can copy source or internal IDs. So source ID are the same IDs which are used in the authoring tool. If you are using BIM Collab and BIM Collab add-ins for coordination issues between different teams, you can also use the inbuilt add-in for collaboration, and that's a Bcf Manager. And Bcf Manager is add-in which is included in BEXEL Manager, and it's also can be downloaded from the BIM Collab site. And this BIM Manager can be installed in almost all other authoring, in all BIM authoring tools, and also for the most of BIM analysis tools as well. So you can, without any issues, share your problems with the participants in the project using the BCF Manager. And if you want to use it, then we can just open the BCF Manager window, which is also positioned by default in the right part of the screen, in the same place where you can access the properties. You can access the level map, which will be talked about later on, and also BCF Manager. So you can easily just drag and drop the found issues in this window, or you can create new issues by selecting and making issues one by one. So there's several ways how you can do it. One of the simple ways, just find the issue, create it, And you can provide your comments, you can specify the date, and when the milestone for resolving this issue is supposed to be happened. And also you can choose whether you want to provide or create issue with only selected element or from all visible elements in your view. So now I'm gonna save all visible elements and create my issue, and that's it. And we can do that for each issue by separately or by selecting all duplicated elements and just drag and dropping all the issues right here in the BCF add-in, and the automatically systems creates all these issues. So double clicking here, the system automatically creates the camera around the found issue. And then we can use the options to connect to the BIM Collab project, which is online. And if you're using BIM Collab, you can use that to automatically collaborate these issues online with the participants, or otherwise you can create a BCF file. And then by creating the BCF file, you can create your new issues, and we can save this file, new duplicate elements, and then provide these to the other participants on the project, and then they can load these issues in the respective authoring tool. So this is how you can easily identify your duplicated elements. And then in different ways, you can collaborate with other participants in order to delete these elements from the project. This way of presenting the issues, found issues or found clashes, is just another way of presenting within the 3D view. And you see automatically when you start your BIM clash analysis and the listed issues, the clash view mode is enabled. If you want to disable it, you can just click on this small tool here and disable clash view mode, and then use the normal view mode, normal 3D views with the ability to see all your BIM model elements regularly. All the options which are used in the clash view mode can be accessed using the option for the clashes in the right part of this window. And then you can specify the way how you want to present your clashes and the elements which are included in the clashes and all other elements which are not visible as well. So here you can specify how you want to see all the elements and the clashes as well. And you can play with these settings. I'm not going to explain them in depth because these are all covered in the common YouTube tutorials. Now I'm going to explain how you can do different types of clash detection, not just by doing these common and fast duplicate clash detection. Also, the other way how you can resolve these issues, but this is something that we do not recommend because the main workflow is to wait and actually collaborate with the design teams and all the people who are actually responsible to create the BIM model. But in case that the design is completed and you got your BIM model and you have to make some kind of analysis, and design teams finish their jobs and you have to struggle with whatever you have currently, then you can actually handle out these situations by selecting duplicated elements from your BIM model and then creating additional, for example, selection sets. So you can always know which are the duplicated elements and you will always know when to include or exclude these elements from any analysis that you want to perform later on, or the other way, which we do not recommend, but it's also possible within the BEXEL Manager is just to delete these elements from your BIM model. But if you update your BIM model and these elements are still present, then duplicates are going to be updated again. So you have the ability just to delete any element from your BIM model using delete option from your keyboard, and that's it. Now I will not delete these elements. I'm just explaining a way how you can handle these situations as well. But if you want to check your different disciplines for coordination and for the clashes, which is one of the very important processes in the BIM analysis, then you want to create different clash detection jobs or different clash detection analysis for different purposes, checking different disciplines and different types of the elements. And usually when people talk about that, usually all these issues and all these different types of clash detection analysis are binded with a clash detection matrix, which is usually something it's defined by the client or other stakeholders, or it's actually stated in the BIM execution plans. So this document usually looks like this with additional explanations, but basically what is visible and what is relevant and important is that you have listed all your disciplines, architectural, structure, HVAC or mechanical disciplines, plumbing, drainage, firefighting, electrical, and all the other disciplines which are existing in your project. And then from each of discipline, you can create different selection sets or different sub-disciplines which are supposed to be checked with all other sub-disciplines for collisions. And here you specifying which disciplines are going to checked with other disciplines, and you specifying the rules which are going to be checked for the clashes. And if you have this kind of document, then you can create your clash detection issues using the BEXEL Manager or any other tool for clash detection. In this case, we can specify new clash detection job used for analysis, for example, of clashes between structural elements and MEP elements. And we can do it quite easily just by running new clash detection job from this window right here. And again, the system will bring you up the same window, which is used for duplicates. But in this case, I'm going to show you in lower part of the screen, the option which was automatically enabled last time was duplicate bounds. It was the clash type which we used for the previous analysis. Now we can specify and use some of these other available types for the clash detections. One of these are commonly used hard, which actually check if your different types of the elements or different disciplines are actually let's say penetrating each other with a different angle. Otherwise, if you want to check your B model elements just for some kind of touching, and if your B model elements going parallel between each other and just touching each other, you can use something which is, let's say, more conservative for the clash detection analysis, and that's hard conservative type for the clashes, which will identify not just the clashes and the interferences caused between the elements which are positioned between each other within some specific angle, but even the elements which are parallel to each other and just by touching the faces between each other. And the last way or the last type for the clash detection is the clearance. So if you want to specify the elements for the clashes, even though these elements are not touching each other, but between these elements we have some space, you can use the clearance. And the clearance is usually used when some minimum space between different types of the elements is required. And it's usually used for the electrical and different types of electrical systems and, for example, electrical and pipe system and similar things. So I'm going to present you these few types and how this works. And also the other way of how you, or actually the common way how you create or specify which type of the element which will be checked for the clash with other type of the element is the place where you're specifying that is here. So right here, the system actually shows you all automatically segregated B model elements. And every time when you fire up this screen, you'll be able to see the work sets, the systems, which are automatically segregated from your B model, and also the sources or the B models which are used to create this federated B model. And also, every time when you create new selection sets, all selection sets will be populated here and you can use them for the clash detection analysis. And that's why yesterday I explained that this is really important, and usually you're going to use selection set for a different types of further and the future BIM analysis. And this is where we're going to use, and today I'm going to use selection sets for the clash detection analysis. Because as you may note, we have the structural, MEP, and architectural folders and sub-disciplines, or the, let's say, selection sets, which segregates the structural, mechanical, and architectural elements in some different subtypes. And we're going to use this for the clash detections, because in this case, for example, we're going to follow the clash detection matrix, which says to check the structural beams, columns, slabs, walls, and foundations versus, for example, mechanical or MEP elements. So in this left part of the screen, we can select the elements which we want to check for the collisions. And in the right part of the screen, we're going to select other elements or the disciplines or the subtypes or selection set, whatever you choose, which we want to check for collisions with these previous ones. So in this case, I'm going to select, for example, only HVAC systems. So now we're checking structural elements against HVAC mechanical disciplines. And we can select the plumbing systems, which are also included and related to the HVAC. And this is the way how we tell the system to check structural elements and all these sub-disciplines with all other elements on the right part of the screen. We can specify the name for this specific clash job, and this one is structural versus HVAC systems. And also, if you want to check only these elements on the left part of the screen against the elements on the right part of the screen, you can check the exclude clashes within the group. So if this one is checked, you're going to check only the elements on the left part of the screen versus the elements on the right part of the screen. Otherwise, if this is disabled, then the system will also check if you have some clashes between, for example, structural beams and structural columns and structural foundations and so on. And also it's going to check if you have some clashes between HVAC ducts and HVAC pipes. So these are the differences. In this case, we want to check the elements on the left versus the elements on the right part of the screen and hit the run. After the completion, which is quite fast for the small project, you see the system is showing you that 718 clashes is found. And if we hit OK, these clashes are going to list it here. You see the name of this clash detection job. We can see the overview of all these clashes by clicking the option overview, and then the system will show us something which looks like the clash detection matrix, showing all the sub-disciplines which are included in the clash detection matrix versus other discipline or other sub-discipline or other type, whatever we choose. And then the system shows you the total of the clashes, and you can export sorry, this kind of report as an XML spreadsheet into the Excel. All these found issues are accessible just by double clicking, and the system will show you the clashes included in the clash detection. So we can turn on the visibility for all the elements, and then the system will show us all the elements which are included in the clash. And you can go through entire found issues, and then if it's necessary, you can filter all these found issues additionally. One way is to use this option here and then filter all these issues with advanced filtering system. And in this way, I can isolate only to see, for example, my structural beams and my HVAC mechanical equipment and hit OK. And even if I want to additionally filter these, we can use this filter on the right part of the screen and tell the system, okay, we just want to see structural beams and HVAC mechanical equipment, but only on the, let's say, the second story of the building. And we can use this option right here. So now we see only these issues are listed here. Additionally, you can select any of these columns available, right click on them, and then use additional filtering options. So these are the ways how you can filter found issues. And also wherever you create some filter, if you click the overview, the system will show you filtered overview. And then again, you can export these kind of reports as well. These columns are actually presents you the identified clashes, the IDs, internal IDs for the clash, for the elements which are included in the left part of the screen when we hit the clash job. So if you want to redo your clash job, you can just run clash detection job and rerun it. So all the elements on the left part of the window and their ID, respective ID, are listed here. Then you see the story or the building level where these elements are positioned, and you see the category from which these elements are coming from, and you see for each of these the exact element and the type of these elements. The same thing goes on the right part of the screen. You see the elements of the mechanical subdisciplines, their respective IDs, categories, families, and the stories. And the next thing you can see is the status, which is automatically generated. And this actually shows you that all these issues are new. And you can create additionally different statuses, right clicking on this status, and then changing the status into whatever you choose. So if you think that this is not really clash, or it's some kind of severe clash, or whatever you choose it's supposed to be, you can change the status of this one. And also the system shows you how much one element actually penetrates the other one. I specifically choose this one because the distance is 0, but this means that one element is completely within each other. So if we change opacity of this selected element into, let's say, 40 percentages, you see that this one, this mechanical diffuser, is totally inside of the beam. So if the distance is 0, it usually means that these elements are totally in the other element, and otherwise it's the distance between these elements, and this distance is actually distance of the penetration of one element into the next one. Also, you can create groups of your created clashes, and sometimes it's really convenient to do. So if you think that specific elements are having the clashes with the multiple different types of the elements, for example, one beam, you can also select one element and then filter the clashes of selected element using this option here. So now we see all the clashes which are caused by only one selected element. And these are all these clashes. So we can easily select all these clashes and create a group of all these clashes caused by one element. And you can create these kind of groups. And then when you specify the clash status for the group, all elements within the group will automatically change the status as well. So now I'm just gonna disable all the filters. You see the group of the clashes, and we see all other clashes also available. We can create additionally clash detection reports using the option clash report. And then all these clashes found can be specified how we want to create clash detection report. Also, before that, let me just show you the level map, which is really important when we're going through the clashes. So when you go through your clashes, the level map will show you where exactly the specified clash is in your plan view of your BIM model. And you can include this kind of small representation of your BIM model in your clash detection report. All these options for level map and the visibility of the elements of the level map can be found here within the level map options. So you can see the additional options to present the visibility and how this level map will be presented. And then if you want to create clash detection report, you can specify what will be included to be visible within your clash detection report. For now on, for this time being purpose, I'm gonna create the clash detection report by default, and prior creating my clash detection report, we can choose whether we want to include all clashes in our report, or we want to include just specific selected elements in our report. So depending on the number of the elements which are included, the export process can take some time. So we can specify multiple issues and create clash detection report, or we can just export entire clash detection. I'm gonna select just a few clashes, and then let me just do that. Okay. So we're gonna select all these clashes and export the clash report. By default, the system will ask us if we want to export PDF file or if you want to export HTML file. For this time, I'm gonna export PDF file, and the system will export these clashes found, and this is how the exported report looks like. Also, prior the export, this is the exported clash detection report with selected clashes, which was 65 in total. You have small review of your clashes, and for each detected clash, you see your view or the image of presented clash, your small view where this exactly detected issue is positioned in your building. And then for each detected issues, you see the name, the element explanation or the description of your element which is included in clash detection, the other one which is included in clash, and the location for each of these. Additionally, you can use the comments as well. And this is how the clash detection reports looks like. These IDs are internal IDs, but also priority export you can choose if you want to export the source ID instead. And this is the way how the clash detection job works. Also, I've already shown you, you can automatically shift and actually drag and drop all these found issues in our Bcf Manager, and then the system will automatically create multiple issues, which you can additionally collaborate with other participants on the project. And I'm going to briefly present how this workflow actually looks like. Uh, as I've explained previously, you can use the online, but in this case, I'm going to use just BCF file, which you can send to your participants on the project. And then if your authoring teams and design teams are actually using, in this case, Revit, for example, for design, I can open my Revit file, which have a structural BIM model and linked with the MEP model. I also have already installed BCF Manager from the BIM Collab, and I can open this saved BCF file provided by other stakeholders on the project, and automatically all these issues are listed here, and we can go through these by just double clicking here, and the system will automatically create the view showing the exact same issue. So you see this is the issue, and you can easily now in the authoring tool resolve the issue. And you can do that for all the issues, all found issues. The system automatically creates, and this is really, really useful for collaboration. So this is the way how you can collaborate with other participants. And also I'm going to briefly show you the other way or the other option for creating the clashes, choosing the clearances and the difference between this one that we already explained. So if you want to check, for example, your electrical equipment and plumbing elements, we can run new clash detection job. We're going to call it electrical versus plumbing. And in this case, we can select also, again, from all these available segregation of your B model, we can choose whatever we want. In this case, again, I'm going to choose mechanical selection sets or the elements from selection sets. And in this case, I'm going to choose all electrical elements. By hitting space in my keyboard, all these are automatically checked. And on the right part of the screen, I'm going to deselect all and use only, for example, plumbing elements. And in this case, we want to check the clearance, or we want to make sure that, for example, distance, minimum distance between the elements on the left part of the window and the elements on the right part of the window are at least, for example, let's say 40 centimeters. So I'm going to put the 0.4 meters in the clearance and hit run. So the system actually found only one clash or only one element which have the distance which is less than this one specified here. So we can easily find it here, and that's it. And the system also shows you the distance between these two elements. And you can repeat this for all other types of the elements or disciplines of your B model elements. And it's really, really easy and fast way of identifying the issues and collaborating the issues with other participants on the project. I think this is clear. Let me just briefly check if you have some questions for the clashes before we continue with the quantity takeoffs. Can you create various selection sets in the same way that custom breakdown? Currently, you can create the selection sets in the way I presented yesterday, but in the next features, in the next releases of the BEXEL Manager, we plan to include the new feature which will enable you to create selection sets in more, let's say, flexible and more and faster way, similarly as you create your custom breakdowns. Workflow to fix the clashes in the native file include Bcf use. And there were some problems in the previous Salibri. I want to be sure that all working well. Well, if you're talking about the issues related to the BCF, then I think the best way is to communicate with a BIM collab, because they are actually responsible for that add-in. We are including that add-in, but basically this is something that they approving as well. Could you please show a sample of exporting the issues as a BCF, including 5 clashes, including revisioning and sending back to the BCF to BEXEL Manager? Well, actually, I think I did it. I exported BCF file, imported into Revit, and then the authoring tool can be used to resolve the clashes. And also, when we finish the explanation of quantity takeoff, I'm gonna update entire BEXEL Manager project, and I'm gonna show you how all these identified clashes and also created quantity takeoffs are also automatically updated as well. So no more questions regarding clash detection. So I think it's clear. Then we can continue with the quantity takeoff. So the next step or the next thing, which is actually coming up in the BIM analysis processes, is that you want to calculate your quantities based on the available BIM model, and then according to the available quantities, then you can further on quantify the expenses and also create some cost estimates and similar things. So if you want to create quantity takeoffs from the BIM model, we also have a tool for that. The module for quantity takeoff is also positioned in the lower part of the screen. So if you hit quantity takeoff, then the new window appears again. And again, I'm showing you purposely on this sample model without anything created automatically. So I'm gonna show you how you can create your quantity takeoffs from scratch. And usually, again, for the quantity takeoffs, you using selection sets most frequently, or you can create quantity takeoffs from available categories or the file types, family types of your B model. So how it works, if you want to create quantity takeoff for selected elements, and this is really, really something that is not so commonly used, but usually if you want to make some kind of brief analysis of quantities of selected elements, we can select multiple elements from the B model just by selecting these elements one by one, or using already available system-based segregation, and then select, for example, all, let's say, structural columns and beams from the B model on the both buildings. I can isolate these quite simple, and then calculate the quantities of selected elements. If you want to do that from selected elements, then you can use the option create new quantity takeoff from selected elements. And then the system automatically include 1,347 selected elements In our quantity takeoff, we're gonna call this one beams and columns, and then we can specify or tell the system how to segregate these elements for our quantification. So similarly, as we did that for the custom breakdowns, we can just right click on these edit elements and use specific rule for segregation. So in this case, I can use all these available rules, which are system-based, and always available building levels, categories, family, source, system name, and material, or we can use discrete properties and continuous property in the same way as we did it for segregation within the custom breakdowns. In this case, I'm going to segregate these elements according to, let's say, category, and then according to the family. And we can also colorize these elements similarly by using the option set color coding rule. And only difference between this tool and the custom breakdown is the option to add or to include quantities. So within the quantities, just by right clicking here, we can use and choose which quantity we want to calculate. So by checking the add quantity, we can select from the available um, properties regarding or related to the different types of the quantities. We can choose and filter which quantity we want to calculate. In this case, I want to calculate, let's say, length. We can filter it. Length, we can specify the precision of presented quantities. And I'm going to calculate at the same time volume of these selected elements in this case. So if you hit OK, it's quite fast. System automatically creates quantity takeoffs of selected elements, segregate them according to the categories, and then according to the family types. And you see the colors according to the family types. If I hit right click on my created quantity takeoff, we can edit it. And then usually before you start editing, we recommend to reset your tree and then start new or edit current quantity takeoff or type of segregation. So in this case, I can add additional rule for segregation regarding to the buildings. And we can choose to make this as a first level of our hierarchy. So I can move it or shift it on the top. So when I hit OK, the elements will be segregated according to the buildings and then by categories and the families, as you may see. It's really, really fast, and you see the quantities automatically, but that's not all. Similarly, as you use the custom breakdowns to colorize these elements, we can use the same color-coded view to colorize all the elements according to the quantity takeoff. So instead of using, in the viewer mode, instead of using custom breakdown color coding rules, we can choose quantity takeoff. And now the elements are colorized according to this. All these quantity takeoffs are automatically related to the elements from the BIM model, and we can use the option select elements in the BIM model from this list, or we can choose the auto select. So every time when I select anything in the list of calculated quantities, the system automatically selects the elements in my BIM model. Also, it works around if I selected the beam, we can find the elements in Takeoff. So you can see that internal ID for selected beam is 10937. So we can find it right here, 10937. So that's the one. You see it's selected. If I select something else, it's going to be highlighted. So this is the way how you can create your quantity takeoffs from selected elements. But the best way to create your quantity takeoffs is creating new quantity takeoffs from blanks, and then you can use whatever you want to create or include your BIM model elements in the quantity takeoffs using available segregation, automatically available segregations from the buildings, stories, categories, families, selection sets. So you can choose, or in this case, I can use everything from my project to be automatically calculated, and then I can segregate it according to specific rule. So in this case, we can use the same way of segregation according to the building, let's say. This is something that you usually and commonly do, always segregate the elements according to the building, and then according to, let's say, the family or the category. But in this case, we can also use additional discrete property for segregation. So you can use, for example, uniformat code or any available property from your BIM model element, and then segregate the elements according to that. And then you can colorize the elements also in the same way, and then you can choose which quantities you want to calculate. And we can calculate, for example, areas, volumes at the same time for all included elements. And length, and we can also count all these elements included in the quantification. So it's quantification for entire building or entire project based on uniformat code. So if we hit OK, the system automatically creates new custom quantity takeoff for all the elements. All elements are automatically segregated in the buildings and the categories, and then each category is additionally segregated according to uniformat code. We can edit this quite easily and, for example, make the uniformat as the hierarchy above, and then we can hit OK. The system refreshes almost instantly. So you see is this the other way of segregation and quantification of your BIM model elements. And then you can select and isolate these elements from your BIM model, and also what is the best, let's say, one of the best features is that you can export all these calculated quantities into Excel spreadsheets. Also, one of the tips is if you included just specific BIM model elements, as we did in a previous quantity takeoffs, all your created quantity takeoffs are listed right here, and you can scroll through all these available quantities. You can hide them. You can change the way how they're gonna be presented here. Hit OK. And also for all these different types of quantities, generated quantities, you can use the option to isolate the elements which are only included in that specific quantity takeoff. So in the previous one, when we just calculated quantities of beams and columns, we can choose to see only beams and columns, or we can choose to see entire project, but only elements which are colorized are included in the quantity takeoff. All other grayish elements are not included in the quantity takeoff. In our entire project, everything is included, so everything has its color, and we can easily export these kinds of quantity takeoffs using the export tool. And then you can choose different options. So I'm going to present you default and then difference between style report as well. So default export looks like this. And also depending on the quantity and the number of the elements, and this export takes some time. In this case, it's quite fast. So this is how the exported quantity takeoff looks like. You see the system automatically creates 3 sheets because we told the system to export. When we hit the export, we told them to create a flat table and then the breakdown structure with the elements. So it also creates flat table, which you can choose and let's say reorganize, create new pivot tables if it's needed. So you can create the pivot tables from this and reorganize and group the elements in the way you like. So the system will calculate the quantities automatically from this. In the way you like, or let me just here, or you can use automatically generated breakdown structure and breakdown structure with the elements. This breakdown structure is identical structure as you may see here. So you see the uniformat and then the types of the elements and the quantities which are included in the quantity takeoff. But additional way how you can export your quantities is by selecting the style report, and then we can choose the system to also include some visual representation of the included quantities. So in this case, I'm gonna unselect fit elements to bounds. So in this case, the screenshots will be created using this camera position for the next images that the system will automatically create. And depending on the number of these quantity items, the system will take some time. So we can replace already created quantity takeoff. I'm gonna close it. So the system exports it. And this is how the exported quantity takeoff reports with a visual representation looks like. So you see the first sheet is new one with a style report. And here you may see all these small items, quantity items regarding to the specific element. And this one is for the beams, or you can see the building segregation, the buildings, uniformat, and then the type of the elements and the quantities. And you can do that for entire building, for each item depending on the number of the items and the number of and the size of your building. And this is really, really useful to actually explain every participants on the project which exactly element is included in your quantification. So you are avoiding some kind of understanding if this part of the element is included, if this phase of the building is included in the quantities and similar things. Also, I'm going to present you briefly how you can use additional way of segregation on a different types of the project and how it works. This was really small project with, let's say, 20, around 20,000 of the elements within the project information. We can see that, or actually 12,000 of the elements. But now I'm going to open one, let's say, bigger project. And here I'm going to present you how you can create quantity takeoffs for, let's say, the rooms using different properties available. In this case, I'm going to use already created scenes. And now you see all the rooms in our buildings, and each room have specific properties. And if we want to choose and include this kind of information regarding types of the rooms, number of the rooms, description, and the names of specific elements, in this case rooms, but you can choose any property from your BIM project, we can create quantity takeoff. Let me go to the quantity takeoff, create new from the blanks. And in this case, we can choose only to include our rooms or the spaces in the quantification. And here we can organize our quantity takeoff of the rooms based on, let's say, department using discrete property. So using discrete property, we can segregate the elements according to the properties. So I'm going to choose department from the list of the properties, and then I can additionally segregate it according to additional property, which is in this case could be the name of the room. And then we can quantify the area of the rooms using add quantity. But also I'm going to colorize these according to the, let's say, name or department. So these are the rooms. Hit OK. And it's quite fast. And this model has actually a lot more elements. It's almost, well, 50,000 of the elements. So you see we have department and the name of the room and the area. But what I wanted to show you is how you can additionally segregate these using the quantity, discrete quantity, instead of actually quantifying summary. So if you want to calculate the summaries of your, let's say, volume, area, and something like that, you can use the quantities. But if you want to present other properties and other values of the properties within the additional columns here, we can choose include discrete quantity. And in this way, I can present, let's say, the number of the rooms and the floor finishes or on any other available property as specific column and information within it. So I'm going to use the comment. So you see the comments included in the quantities. So the comment will not be summarized, but the information will be visible. And also I'm going to use, in this case, floor finish, because we have the information about it added in the properties of the room. And also another way or another property is number of the room. And if I hit OK, so the system actually shows you additional columns with the number of the elements, floor finish within each room, and the number of each room. And then we can see the colorized elements according to this. And it's really, really useful, and you can easily create the style report with this kind of information. So depending on the number of the elements and the size of the project, it also takes some time. And this is how the created report looks like. So you see different rooms with different type, and you see the area, and you actually see where specific type of the room is positioned in your building. And then you can see the breakdown structures similar as we see it in the BEXEL Manager. And also I'm going to show you just briefly another quite large project and how fast you can work This project has actually more than, let me check, 400,000 elements within itself. And this is how fast all these quantity takeoffs works. So you can automatically see it works quite fast for entire big projects, depending on the number of the elements and types of segregation. So if I choose to segregate this differently, so let's say just colorize this according to the category, hit OK. That's it. Quite fast, and you can save multiple quantity takeoffs for the project, and then you can load them and analyze the project according to that. These are the pipes, and you can see the size of the pipes from the loaded um, quantity takeoff. And also, before we conclude today's session, I'm going to briefly show you this created quantity takeoff and the project when it's saved, and how the system automatically updates all the information when the project is updated. So I've saved it. I'm going to close the project, and then I'm going to update the project with additional, or let's say updated, mechanical and structural elements. So I'm going to choose the project from the versions. This was the previous one, and we're going to update it. With, let's say, structural and mechanical source. So when this is completed, let me just, in the meantime, I'm going to try to respond to your questions. So the system asks us to match the source. So this one is structural, or this one is the new one, mechanical building. And this one is the structural one. Okay. And this one is for a building 2. And hit OK. In the meantime, I'm going to read your questions. Is it possible to define the clearance is the bottom, top, or on the side of the elements? The clearance actually takes in consideration all the sides of your elements, not just the sides, but also from the top and from the bottom. I'm going to open the updated project. What is the important advance of the quantity takeoff? I think you see it already. The advantage of creating quantity takeoffs is the flexibility and how fast and accurately you can generate different kinds of quantity takeoffs. Almost instantly, in a minute, you calculate the quantities, and also once you created your quantity takeoffs, you can update the project as I did now, and you can see the updated quantities automatically, and everything is updated automatically. And now we have, even for the building 2, which have MEP elements, these MEP elements are included in our quantity takeoff. You can see this one is automatically included right here. So everything is automatically included because all these newly added elements are already included in the selection sets or in other types of segregation which is used for quantity takeoffs. And also, if we go to the clash detection, we updated the building. So if we go to the, let's say, structural and HVAC, we can do the update, and then the system will automatically check if we have the new clashes, and now you see previously identified clashes are marked as active, and the new created are actually automatically have the status new. And these are mainly for the second building. So I'm gonna continue with your questions. Can we take reinforcement steel quantities? Yes, of course. Any available element can be used for quantification, and using the properties of these elements, you can calculate the quantities. Regarding that in Takeoff, the choices are as a group, as category, families, etc. More close to Revit. Are any samples of IFC working files exported from ArchiCAD or Open Buildings Designer? I can open you any other building. Let me just find this one is actually the building I showed you yesterday. And this one is infrastructure project, which is created in Pro-V. These are all elements exported in the IFC file. So let me just show it right here. Go to our 3D view, and we can automatically use any type of available segregation, because I'm not really familiar with the German language, but I can create new quantity takeoff. This one is actually project from the IFC. We can go to the sources. You can see the source is IFC file, and we can create new quantity takeoff from entire project. And we can segregate these according to the buildings. And then I'm going to use the segregation according to these, let's say, elements, because I'm not really familiar with the project. And I'm going to calculate also, because I'm not really familiar with the project. Let me just try to find areas or the volumes, largest projected area, because this one property is available from the project. And also I'm going to try to find the volume. Well, probably it's differently called the property. Let me just try to find something else. Let's use this one and colorize the element by the family. So the system will automatically create quantity takeoff, segregation according to the one we specified. I can go to the color coded and see the building according to these colors from the quantity takeoffs. And we can easily select these elements from the BIM model. I can try to, this is the one. This is quite a large project, so it's not easy to identify all the elements, but it doesn't matter which source you're using, which type of the elements you're using, the quantification works anyway, because it uses segregation according to your needs, and it using the properties available in your project to calculate the quantities. Can we take quantity of painting, joinery? Well, all the properties available can be used to quantification. If you have specific property regarding to the area of the paints or the joints, whatever you have, it can be used to quantification. Can the system detect different parts of the model which may have not been quantified in the model, like staircase bottom, surface area, or similar? Well, this is something that you have to be familiar with. So you have to know limitation of the authoring tool and which properties the authoring tool which not provides you. So the BEXEL Manager uses the properties and the quantities which are coming from the authoring tool. So if your authoring tool do not provide the surface area of the staircases from the bottom or similar things, that will not be calculated in the BEXEL manager neither. We're using the available properties. Other way, you can use these elements which do not have specific properties. You can create new properties using the, let's say, additional ways how you can calculate new property using available properties and then calculate it with specific formula. So you can choose some available property and multiply it with something, with some formula, or multiply it with some other property and create. In this way, you can create new properties. And then you can use this newly created property to calculate your quantities. These were the questions in your Q&A. Let me check if you have some questions in the chat. I don't think so. So if no more questions, I think we covered the quantity takeoff and clash detection module, and we're gonna see you and hear each other next week with the new sessions. Thank you very much, and see you next week.